By the end of this lecture, you should be able to explain why it is important to add control variables to a regression, interpret the results of a multiple regression in SPSS, and calculate estimates from a multiple regression. Before I move on to new material, I would like to review some material from the previous lectures. In the previous lectures, I showed you how to use a bivariate regression to determine whether one independent variable has a statistical impact on a dependent variable. Bivariate regression produces the following equation. Dependent variable hat equals b hat times the independent variable plus a hat. B hat tells us the effect of the independent variable has on the dependent variable. If the independent variable has no discernible effect on the dependent variable, then b hat would be equal to 0. As the independent variable increases, the dependent variable stays the same. However, we expect the independent variable to have an effect on the dependent variable, so we don't expect the coefficient b hat to be 0. Based on our hypothesis, we expect it to be greater than 0 or less than 0. If we expect there to be a positive relationship between our independent and dependent variables, we expect that as the independent variable increases, the dependent variable increases. Hence, the coefficient b hat for this line would be greater than 0 or positive. If we expect there to be a negative relationship between our independent and dependent variables, we expect that as the independent variable increases, the dependent variable decreases. Hence, the coefficient b hat for this line should be less than 0 or negative. Now we're going to move on to discuss how we can use regression to analyze whether multiple independent variables have an effect on a dependent variable. In most cases, we do not expect one independent variable to have an effect on a dependent variable. Instead, we expect multiple independent variables to have an effect on a dependent variable. When this is the case, we run a multiple regression. It is called multiple because we use multiple independent variables. Multiple regression produces the following equation. B hat equals b hat 1 times the independent variable 1 plus b hat 2 times the independent variable 2 plus a hat plus e hat. Note that this is what we call a partial regression coefficient, or b hat, for each independent variable. And note the subscripts tell us which b hat belongs to which independent variable. So b hat 1 belongs to independent variable 1 and b hat 2 belongs to independent variable 2. Each b hat tells us the effect of each independent variable on the dependent variable while taking into account the other independent variables. There are several reasons why we should control for our other independent variables in our regression models. First, many independent variables can affect a dependent variable. If we leave out an important independent variable out of our model, we are leaving important information out of the model. If the model does not take into account the other information, it might think the other independent variables have a greater impact on the dependent variable or a lesser impact on the dependent variable. As a result, the b hats of the other independent variables might not reflect the true b hats for those variables. For example, let's say we were interested in figuring out which factors led some voters to be more conservative than others. We think that income has a strong impact on conservativeness of voters. So let's say we ran a hypothetical bivariate regression with conservativeness as the dependent variable and income as the independent variable. The b hat for income turned out to be 0.06. Now we could say that education also has an important impact on how conservative a voter is, but we did not include that in our bivariate regression. So to take this new information into account, we add education to our model as an independent variable and run a multiple regression. As you can see, the b hat for income gets bigger. Because we did not include education in our first model, we underestimated the effect that income had on conservativeness. Another reason we run multiple regression is that it allows us to make better estimates of our dependent variable. Since we are including multiple independent variables, it allows us to take into account more factors that explain variation in our dependent variable, leading us to make better estimates of our dependent variable. And if we make better estimates of our dependent variable, that leads to a reduction in our errors. And since our estimates of the dependent variable for individual observations will be closer to the true values of the dependent variable for individual observations, our errors will be smaller. And a reduction in error leads to a higher R-square and adjusted R-square, meaning our models are explaining more of the variation in our dependent variable. Last, we also run multiple regression because a significant coefficient in a bivariate regression does not necessarily mean the independent variable has an effect on the dependent variable. If the independent variable is related to the true causal independent variable, it will seem like there is a statistical relationship between the independent and dependent variables in a bivariate regression. However, the independent variable really does not have an effect on the dependent variable. It is the true causal variable that is driving the relationship, but we did not include that true causal variable in our bivariate regression. This phenomenon is what is known as a spurious relationship. Hence, we need to include more independent variables in our models just to make sure our results are not driven by spurious relationships. So for example, let's say education has a true causal impact on conservativeness, but we don't know that. We just think income does. So we run a bivariate regression model with income as the only independent variable, and it turns out that income does have a positive statistical effect on conservativeness. But the only reason why income has a statistical impact is because education and income are correlated. In this case, income is acting like a proxy variable for education in the model. It may look like people with higher incomes are more conservative, but that is only because people with higher incomes are more educated, and more educated people are conservative. If this is the case when we run a multiple regression model, income may become insignificant and education significant, meaning that education influences conservativeness, not income.